Assalamualaikum warahmatullahi wabarakatuh. Today I want to present about Integrated Design Project IDP for Group 2. We conduct to PLC course and Electrical Power Laboratory course. So we have to do IDP 1 and IDP 2. For group members, myself, Ahmad Irfan bin Ahmad Shukran, DN 2084, Christo Blun Anak Joni, CN 200003, Ahmad Farhan bin Amir Junaidi, AN 2050. For objective of IDP, we can analyze the PLC programming using different process description to control and automation system for various application. Number 2, can categorize the fundamental of power system and motor control starter components based on theoretical. We are able to program, testing, and troubleshooting the error in PLC programming by using CS Programmer software to solve the engineering problems. Conduct 3 types of case study to generate the motor beside using the ladder diagram on CS Programmer software. And lastly, demonstrate ability to apply the theoretical knowledge on the electrical power system, industrial motor control starter, and thus to work efficiently as an individual and as a member or leader in solving relative problem. List of component, we have Omron PLC C.E, power supply, protector, circuit breaker, mounted case circuit breaker, thermal overload relay, DC 24 to PDT non-ratching relay plug-in, push button, and LED indicator. For case study statement, case study 1 is direct online starter doll. The motor will develop lock rotor torque and begin to accelerate towards full speed. As the motor accelerates, the current will begin to drop, but will not drop significantly until the motor is at high speed, typically about 85% of synchronous speed. Component that we use is power supply 1 Omron PLC, 1 Tor, 1 contactor, non-ratching relay 1 circuit breaker, 1 MCCB, 2 push button, and 2 LED indicator. When push button green is pressed, the motor will generate. When stop button red is pressed, the motor will be stopped slowly. Case study number 2 is forward reverse starter. This we conduct 3 push button to control the motor. This is mechanical interlock that stop both coil from pulling in simultaneously its feet between 2 standard contactors to create a forward reverse motor starter. Component that we use was 1 power supply, 1 Omron PLC, 1 Tor, 2 contactor, 1 ratchet relay, 1 CB, 1 MCCB, 3 push button, and 3 LED indicator. When push button 1 is pressed, the motor will generate forward starter motor and press the stop button to stop the motor. While press the push button 2, it will generate reverse starter motor. Press stop button again to start the motor. For case study number 3 is for reverse starter with timer. This is quite same for case study 2. We just add timer in ladder diagram. As the working principle, when push button 1 is pressed, the timer will be count about 5 seconds. After that, motor will generate to forward direction. Push stop button to stop the motor. When push button 2 is pressed, the timer will be count about 5 seconds. After that, motor will generate to reverse direction. Push stop button to stop the motor.
Salam sejahtera to Dr. Sumbaya and also Puan Rashida. My name is Christo Blun Anak Joni from Group 2, and I'm going to present the experimental setup with label and connection to 3-phase AC motor. So first we're gonna look at the without PLC. So this is our circuit without the PLC. So this circuit was taken picture when it is connected for the forward reverse connection. So this is how the connection looks like. So this is our label. So this is the main circuit breaker, MSSB. This is a miniature circuit breaker. This is the button for doll, direct online starter. This is the lights for doll, the run light and also the trip light. This is the contactor for doll, and then contactor for forward, contactor for reverse, Tor for doll, and Tor for reverse. We in this experiment, in this project, we use 2 Tors, so that is easy for us to identify which circuit is which. So this is the button for forward reverse and light for forward reverse. Okay, so this is our schematic diagram for without PLC. So the schematic is what we already did in the electrical power lab. So it is a combine of the direct online starter as well as the default reverse starter. So here from the power circuit, then we go to the miniature circuit breaker and then to the TOR. Is at the TOR is where we loop the circuit together to make it into one. So as you can see here, TOR, and then here is already the for reverse, and this maintains the doll. So everything is the same. We just loop the TOR, similar to our motor circuit. So here our connection for the circuit is from the red, yellow, blue power source to the MCCB. So from the MCCB, it goes into the contactor. So the contactor is where we loop it. So from the door contactor, we loop it to the forward contactor, then goes to the reverse contactor. So we loop it here, we loop the power source of the contactor here, and then the output is the motor. It goes inside the respective the TOR, the on TOR. Each, like I said, two circuit has each TOR, the on TORs. So it goes into the on TORs here and here. So okay, this is our result. So first I want to show this video. This is the TOR video. This is the direct online starter video for the mechanical without PLC. On, start, off, okay, finish. So that is, and then this is the forward reverse video. Forward is green, stop, and then reverse is orange. See, stop. So that is our result once we connected the circuits. Okay, back to this is the setup with PLC. The setup with PLC is similar to the one that we already did. It's just that we add PLC, push the button for doll. We didn't want to use this button yet because we don't understand the connection at first. So we add another 2 more buttons. So that's why we have another button here. But it's okay when we do our forward reverse for PLC. We use the forward reverse button. We modify it. So this is the power source 24 volt DC. Yeah, it is the same. I don't label everything because I'm afraid they have no space to label. Takut tak ada tempat banyak-banyak label nanti. Susah juga nak tengok. Okay, so this is the PLC with doll. So from here, from the power line, goes up into the line, goes into the line of the PLC. Neutral. Then the earth goes to earth, and then the COM goes to COM. Yeah, COM. And then the positive is for to control the start and stop of the circuit. So this is our input in 0.00, input for start, input for stop is 0.01, then the output is 0.00. So and then this is the relay, we add the relay. So the relay is directly connected to the contactor here. So it goes to neutral. So this is our connection with the PLC for forward reverse. It is the same, it's just that we have 2 outputs now. This is for forward, this is for reverse. So 3 buttons for forward, reverse, and then stop. The input 0.00, 0.01, and 0.02. Output is 100.0 and 100.01. So again, it is similar, but we just have 2 contactors for reverse. And then for the circuit, for the motor circuit, the 3-phase motor circuit, it is the same as well. If we look inside the instruction manual here, so it is the connection circuit is the same. So we just use the connection circuit for the mechanical part, and mechanical part, and the PLC part is the same for fundamental connection. So what changed is mainly the control circuit part, so that we don't have and also because this is PLC, so PLC we can control the circuit using the ladder diagram that we upload in the PLC. So that is the difference for me. I think we can have the same circuit, but we can change the outcome by just changing the ladder diagram and upload the PLC without even changing much of the circuit. That's the good part about using PLC for me. Okay, so the video for our findings. Okay, this is the doll. And fast forward. Okay, so when we press start, you can see here it's moving. Then we stop. Then we start again. Still it's moving. So this is for doll. So for the forward reverse PLC, on, start, off, reverse, yellow, on, then stop. This is our finding for the PLC, for the forward reverse PLC, and then this is the forward reverse timer. So we press this, wait 5 seconds, on, okay. Then we stop, then press reverse, we wait 3 seconds, on, yellow, okay. So this is our finding. So like I said, for the connection, there is not much difference. Even if we look here, so this is the MCCB, it's gonna loop here. Like I said, the MCCB, the power, loop to the doll contactor, doll will loop to the forward, then the forward will loop to the reverse contactor, and then the output from the reverse contactor will go inside the be connected to the reverse following this diagram. I think this one is this the second one. So the yellow will loop to the red, and then the red will go to the yellow. So it's like that. It is connected here, and the output, then this is the output, directly goes to the motor. So the motor here, and then this is where we loop the RS a UVW loop together, and then this the neutral goes back to the also workbench. So I think that is all from me for my part of presentation. So thank you.
Okay, for discussion, for number one, prefer control system. We more prefer to dual system. It is because it is simple and most economical starter, more comfortable to design, operate, and control, easy to understand and troubleshoot, and can be applied to any electrical system. Problem and troubleshooting. We have a problem when make a connection for the new components such as relay, power supply, 24 volt, and PLC C1E. We have ever tried this component, this new component that we make. For troubleshooting, there was a trial and error process, a lot of and asking for help for our lecturer and our classmate to solve this problem. We also try to make a research on Google to make sure the connection is right. So lastly, we can make a good connection for our board. For conclusion, we learn to connect the PLC system with the electrical board using the components provided. By basing knowledge on the subject of PLC, we can modify various working principles that can be applied on electrical boards. For example, we can create a dual and fault reverse system by constructing a ladder diagram corresponding to the associated system. We were also able to master and challenge ourselves to assemble all the separate components into a system complete with components on an electrical board. Components such as circuit breaker, MCCB, TOR, and contactor that we have wired neatly and efficiently so that the system can run smoothly. Finally, with this knowledge, we can apply the PLC system and electrical wiring very well when working outside. Thank you.